We want to describe the graphs of quantitative data. What we're going to first focus on is the overall pattern, the shapes. Let's look at the first types of shape. We're going to look at symmetric and roughly symmetric. A symmetric graph has a distribution where the left and right have a perfectly mirrored around the center. Here is our example graph. On the left side, we have 1, 4, 1, 5, 3, 6. And on the right side, we have also 1, 10, 1, 9, and 3, 8. Symmetrically, with a centered peak, here we see that we have a centered peak of the value of 7, and we have a total of 6 values of 7. Also, we sometimes called symmetric graphs bell-shaped or bell curves. If we were to sketch a line that touches each of the corner, we'll end up sketching a graph that mirrors a bell, or we'll end up sketching a graph that looks like a bell, something like this. We have a curve that goes up and down, both same on left and right, and it simulates or it looks like a bell. Let's look at roughly symmetric. A distribution is roughly symmetric if one side containing the largest half of the observations mirrors the other side. Let's look at this example here. If we think about 5 representing the center with 8 values, on the left side, there are 3 2s and 4 4s, whereas on the right side, there are 2 7s and 3 6. The left side is larger than the right side, but only slightly. We would consider this slight larger side as roughly symmetric. If we were to connect each of the tips of our bar graphs, the left corners on the left side and the right corners of the right side, we will still get a graph that is roughly bell-shaped. So we can still say they are bell-like in shape when we're talking about roughly symmetric. Let's compare a symmetric graph right next to a roughly symmetric graph. We can see that in a symmetric graph, the left side mirrors the right side exactly when we're looking at the major peak or the center. Whereas roughly symmetric, one of the sides are slightly larger than the other side. However, if we were to sketch out a curve on top, it will look roughly symmetric or roughly bell-like. And that's symmetric and roughly symmetric graphs. The next graphs we're going to look at are skewed to the right or skewed to the left. Skewed to the right or positive skewed, the right side of the graph is much longer than the left side. We want to think about it as a tail on the right. Let's take a look at this picture. If we were to sketch over this picture and connect all the corner, we'll get a tail or a side that is longer than the other. So when we're thinking about a tail here, let's think about drawing a little picture for this. How about if we put a little dinosaur face? And for our dinosaur, its tail is on the right, meaning we have a main body and an extended right side that represent our tail. Similarly, let's look at left skewed. Similarly, let's look at skewed to the left, or sometimes we call it negative skewed. The left side of the graph is much longer than the right side, meaning there is some kind of tail on the left. Let's check out our left skewed graph. Again, if we're connecting each of the tips of our bar graphs, and let's just sketch out a picture, we'll have our main body on the right side, and we can think about creating a little fun little creature. And on the left for our main body, we can add in little spikes to represent the tail. So this picture or this graph is skewed to the left. Now let's talk about bimodal and unimodal. A bimodal distribution has two peaks modes that can occur. So we're looking for two modes, meaning we're looking for two peaks that have the exact same height, anywhere within the data range separated by a trough, a lower point. Let's look at our picture here. This is a bimodal distribution because it has two peaks that have the exact same value, meaning it has two equal high points and is separated by a trough, meaning some kind of dip below. So we have peak 1 and peak 2. Now let's look at a unimodal. Two unimodal one-peaked distributions are graphed on the same axis. When the peaks have unequal heights, the higher apex is called the major mode and the lower one is the minor mode. Let's take a look at our picture. So we want to first look at the major mode. The major mode would be the highest of the two peaks. The minor mode would be the second peak that is separated between each other with also a trough. One thing to note when we're looking at bimodal and unimodal, sometimes our unimodal is considered a bimodal in certain books. If that's the case, the major mode and the minor mode will be considered the two peak modes. So in some books, we will consider bimodal and unimodal the same. It just becomes book dependent or definition dependent. However, here we are clearly stating that a bimodal distribution has two modes that are exactly the same value with a trough in between, where we have a two unimodal has a major mode, meaning a single high peak, followed by a minor mode, meaning a secondary high peak that is close and is separated by a trough. And that's bimodal and unimodal. We're going to continue with another bimodal and unimodal type of graph called a U-shaped graph. A U-shaped distribution is one which the frequency of data points is higher at both extremes, the lower and upper ends, and lower in the middle. So it still has a trough. On one end, we have a high point, and all the way on the other end, we have a second point. In this situation, we'll consider this one as a unimodal. We have a major mode on the left, one, and a minor modal on the right. A U-shaped graph can also be a bimodal if both the extreme left and right are the same. We do still have that same trough in the middle that separates the two modes, or the two unimodes. We want to make sure we note in the U-shaped graphs, there are no values all the way on the far left and the far right. Let's look at a common example of U-shaped distribution. Example, rating scales from 1 to 10. Product reviews, where people who rate an item either loves or hates it. In this distribution, we have extremes on the ends. So looking at product reviews from 1 to 5 stars, we have a lot of individuals who like the product, giving it 5 stars, and we have a lot of individuals who dislike the product, giving it 1 star. And we have a trough in between. So this is an example of a possible U-shaped distribution where it involves reviewing products from 1 to 5 stars or 5 to 1 stars. The last shape we want to talk about is uniform distribution, and roughly uniform distributions. A uniform distribution has a distribution that is rectangular in shape with the same amount of data for each variable value. Let's look at a quick example. Continuous uniform distribution. When we want to think about continuous uniform distribution, the word continuous will indicate that there will be no breaks. Everything is connected. So to remind us, common continuous quantities would be something like time, height, and age. Random variables can take on any value with a given range or interval, no breaks. Again, review of what continuous is referring to. Here, let's look at our uniform distribution. We have a uniform distribution of wait time for RTA trains. So on the x-axis, we have wait time. On the y-axis, we have a probability of the train arriving. Since time can be broken up into infinitely smaller time frames, we have 1 minute, we can have half a minute, we can have a quarter a minute, we have a tenth of a minute, etc. So this causes our distribution to be continuous. So then how do we understand that it is uniform? When we're thinking about uniform, in any one of these time frames here, the likelihood of the train showing up is the same no matter what. And that's continuous uniform distribution. Let's look at the second case where we have something that's roughly uniform. Let's look at an example. So a discrete uniform distribution, we want to think about values that have breaks in them. So things that don't make sense to cut into smaller sections, like people, whole digits, like integers. In a discrete uniform distribution, random variables can take on a finite or countably infinite number of distinct values. So there'll be breaks. Let's look at an example. The last digit from 47 students' telephone number creates what we call a roughly uniform distribution. Since the digits of a number cannot be broken down, so the digits can only be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And here's our roughly uniform distribution. On the x-axis, we have the last digit of a phone number, and on the y-axis, we have the count. If we draw a horizontal line across the 5 count, we can kind of see that distribution creates a shape that is somewhat rectangular. So here's our rectangular shape distribution. So those are the basic types of distribution we care to go over. We have our skewed left distribution, our skewed right distribution, and then we have our symmetric distribution that we typically state is bell curves or bell shape. Then we have our different modal distribution. We have our bimodal with 2 modes at the very top, our unimodals, which has 2 high peaks, a major mode and a minor mode. Then we have our U-shaped graph, which is an extreme situation where there's no extra values on the side. Then we have our uniform distributions. We have a nice rectangular shape, and we have our roughly uniform where we can draw a rectangle on top of it, and that's describing the shape of our distributions. Next time we'll talk more about central tendencies, which covers mean, median, and mode. I think that's all I care to talk about. Time to disappear.